Which of the following is a combustion reaction? Now we have 4 options here. We'll consider each. So is it option A? Option A is not a combustion reaction, it's a decomposition reaction, as you can see. So option A is not the answer. Option B, which is a carbonate decomposing again. So because it's not reacting with another species, so it's not option B. D is a ionization reaction where hydrogen ion and the hydroxide ion are reacting together to form water. So option D is not the answer. And we're moving to option C, where we have sodium reacting with oxygen. Now oxygen, when it's reacting with oxygen, that's when combustion is happening. So when sodium is reacting with oxygen to form sodium oxide, now that's a combustion reaction. So option C is the answer. Now moving to question 2, which of the following is an oxidation and reduction reaction? So what are the things you have to look for an oxidation and a reduction reaction? There's supposed to be an electron transfer. Now in our first reaction, there can't be an electron transfer because it is a decomposition reaction. So A is not the correct answer. Moving to option B, we have again a decomposition reaction happening. So option B is not the answer because decomposition cannot provide oxidation reduction reactions. Option D is an acid-base reaction. You can see HCl is an acid and NaOH is a base. So when they react, it's a neutralization reaction. So option D is not the answer. Giving us option C, which is iron reacting with oxygen to form iron oxide. Now, iron 3 oxide here is formed by iron and oxygen. So iron would be undergoing oxidation while oxygen would be undergoing reduction to form iron oxide, as you can see. So option C is the answer. Now moving on to question 3, which of the following equation is correctly balanced? So we'll be considering each option one by one. First of all, we have option A, which is the hydrogen atom and the oxygen atoms are not balanced. You can see the hydrogen, there are 2 here and 4 over here. So they're not balanced. And the oxygen, we have 2 here and we have 3 on this side. So they're not balanced, making option A incorrect. Moving on to option B. So option B, we have the hydrogen atoms not being balanced. We have 8 hydrogen atoms but only 4 on this side. So the hydrogens are not balanced. Moving to option D now. Option D has the carbon and the oxygen atoms not balanced because we have only 1 carbon, but we have 2 carbon atoms on this side. So clearly the carbons aren't balanced. What about the oxygen atoms? We have 4 oxygens here, but we have 6 oxygens on this side. So D is not the correct answer. So considering option C, option C has all of atoms balanced. We have 1 carbon, 1 carbon, 4 hydrogens, and we have 4 hydrogens when you times it by 2. We have 4 oxygens and we have 2 oxygens from here and 2 oxygens from here, giving us a total of 4 oxygens. So both sides it's balanced, making C the correct answer. Now moving to question 4, it says write a balanced equation for sodium reacting with oxygen to produce sodium oxide. Now in this case, I would underline these 2 words, sodium and oxygen, because those are our reactants and our product is going to be sodium oxide. Now this is a synthesis reaction, but it is undergoing a combustion reaction as well. So identify the reactants and the products as we have just done and place the reactants at the left hand side and the products at the right hand side of the arrow. So it's just simply writing it there. But then you would have to work out the chemical equation for each. So balance the atoms. Now this, you can't leave it like that. You have to balance your reaction, the atoms on each side of the equation, and inspect whether it is balanced. So here we have 4 sodium molecules reacting with 1 oxygen molecule to give you 2 sodium oxide molecules. And this is a balanced equation. Because it's asking for a balanced equation, it's very important to get your full marks. You should balance your equation. And I would recommend you to write your states if you know the states. But if you're unsure about the states, please leave it out. Now, states at each reactants and products using a bracket. So here we have states written: solid, a gas, and a solid. So you should be able to write the states as well, because it's asking for a complete equation. Now moving to question 5. Question 5 says, write a balanced equation for the combustion of methanol to produce carbon dioxide and water. Now here we have methanol reacting with oxygen to form carbon dioxide and water. Remember, I told you methanol is also a hydrocarbon, which means that all its products under combustion is going to be carbon dioxide and water. So you would first balance the number of hydrogens on each side. You would always start with your hydrogens. So you have 4 hydrogens on this side, and you would have 4 hydrogens on this side. So that's all balanced. 1 carbon, 1 carbon. The oxygens, there are 3 here and 3 here. So this is a balanced equation. So you would have to add a 2 in front of the H2O in order to balance your equation. Now balance the number of oxygen atoms so that the 4 oxygen atoms are on each side. So you would have 4 oxygen atoms on each side. Now that's the thing. When you're going to balance it, you would have a fraction coming along, because you only want 1.5 of molecule of oxygen. In other words, you only want 3 oxygen atoms, but oxygen occurs in a molecule of 2. That means you would need 1.5. So you would write 3 over 2. Now this looks very tedious at the moment. So to make it more simple, you would times each molecule by 2. If you do that, you would add a 2 here. When you times this by 2, the 2's would cancel out, giving you 3 on this one, 2 here, and when you times 2 by 2, you would get 4. So eventually your equation would look like this. You would have 2 methanol reacting with 3 oxygen molecules, giving you 2 carbon dioxide molecules and 4 water molecules, as you can see. Add your states. Of course, you would have to add your states. Methanol is a liquid, which is a fuel. And then we have oxygen, which is a gas, carbon dioxide, a gas, and water as gas, because this is a combustion reaction. In other words, there's going to be high amounts of heat produced, giving water as a gas instead of a liquid. So that brings us to the end of the lesson today. We covered combustion reactions, neutralization reactions, synthesis reactions, decomposition reactions, and many chemical reactions. We also learned how to write chemical formulas and also a chemical reaction. So we learn how to balance our equation and also to add your states.